Now, the periodic table is something that confuses quite a lot of students, so hopefully in this video, we're going to break down everything you need to know when it comes to understanding the periodic table, understanding how to recognize elements, and understanding atomic numbers, mass numbers, and the list goes on. So let's get straight into it. So here we have a really nice diagram of a periodic table. Now, essentially what the periodic table shows us is it shows us all of the elements that are currently known to us. For example, we have hydrogen here, we have helium here, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, and I could continue this for quite literally minutes. I could go through this entire periodic table, but the main ones that you really need to know are the first 20 elements. And the reason why it's the first 20 elements is I've just not thought of that randomly. It is quite literally from the exam board of pretty much every single GCSE paper. So all you really need to know is up to calcium. So as long as you're good with hydrogen, helium, lithium, beryllium, and so on, all the way up to calcium, then you should be good to go. It's worth noting that if you're looking to get those high grades, maybe a 7, 8, or even a 9, then definitely familiarize yourself with all the other elements as well, just so you have a good understanding of the entire periodic table, especially as well if you're studying AS or A level, then you definitely want to be familiar with all of this. Let's actually just break down a couple examples of elements. Now, how I want you to think about elements is elements on the periodic table are pretty much the same as words are on a dictionary. So I always use this as an example. Imagine if I asked you, please could you find me a random word? You don't know the word, but I want you to find me a random word. Well, you would go to a dictionary, you would pick up that dictionary, you would look through the pages and you would find a random word. And if I said to you, could you find me a random element? I would pretty much get you to do the same thing, but instead of picking up a dictionary, I would expect you to get a copy of the periodic table. I'd expect you to look through it and then pick one of these elements like this. If I go ahead and quickly do that exercise, let's go ahead and pick oxygen, which is like this. So O, and then I can see the number 8 right here. Now, this number here represents something called the atomic number. Now, the atomic number is really important because this is what enables a periodic table to be organized. And you'll notice this, hydrogen is 1, helium 2, lithium 3, beryllium 4. So quite literally, the periodic table goes up as the atomic number increases from the element. The atomic number tells us loads of bits of information. We will get to this in a second, I promise. But that is not the only number that is present on the periodic table. Now, another number is also present, and that is known as the mass number. Now, in this diagram I've got here, we have literally just included the atomic numbers because we wanted just to keep it simple. But oxygen also has a mass number. So what I want you to do quickly is I want you to pause this video, go to your data sheet, and I want you to grab the other number that you see with oxygen. Hopefully when you looked, you saw that oxygen had another number associated. It wasn't 8, it was 16. Now that is the mass number. Now we're going to get into the ins and outs of what these numbers mean in a second, but what I want you to do is honestly just pause this video and just go through this example. Just pick loads of different elements. Maybe you can pick boron, maybe you can pick fluorine, maybe you can pick magnesium, and literally just go through the practice of writing them down, identifying the two numbers, and that is quite literally it. And a quick fact that no one seems to understand, I don't know if they just don't teach it in schools, maybe they're just not clear, but the easiest way to memorize the difference between the atomic and the mass number is the mass number is always the larger out of the two, which means the atomic is always the smaller. So imagine if I gave you an example, and let's just say I gave the example of oxygen again, but instead of writing O816 on the top, I wrote O16-8. Using the hack I just said, we know that the larger one of those is the mass number, so I'm going to go ahead and label that the mass, and we know the smaller one is the atomic, so I'm going to go ahead and label that the atomic. That hack has really helped me throughout the years, just really making sure I understand and can recognize the difference between the mass and the atomic. So atomic always is smaller, and the mass is always larger. So what we're going to do now is we're going to go through the first 20 elements that you need to know. Make sure to take notes of this. If you need to pause the video again, just pause it, but let's get straight into it. Here we have our lovely diagram of the first 20 elements. Now, this is really important. For your GCSE, you need to make sure that you understand how to recognize all of these. Now, a very good example of how to implement this is not only do I need to know the symbols, but I need to know the names of these elements. So let's go ahead and run through them. If I just quickly pick a random one, let's just choose P here. Now, P, if I write this out, is P15. This is the atomic number. And again, for good practice, I want you to pause this video and quickly look at your data sheet. And I want you to get me the other number that you see associated with P. If you've done that correctly, then you can see that that number was 30. Now 30 is a larger number out of the two, so we again know that's the mass number. P stands for phosphorus. So if you ever need to write the symbol for phosphorus, you would write P. If you ever need to write actually what P stands for, then you would write phosphorus. Now, you definitely need to make sure you understand, again, I keep saying it, but the difference between the atomic and the mass number. And what I would suggest you do now is quite literally just pick some random elements like this and just go through this exercise. Write down the atomic number, write down the mass number. Just make sure you're comfortable at actually labeling these elements. Go through one more example just to make sure we've covered everything. Let's go ahead and go through Mg. Now, I'm just going to write this out again. Mg, we've been given the atomic number, which is 12. Now, if I look on my periodic table, I would see that the other number associated is 24. Now, out of those two numbers, which is the largest, it's going to be 24. So we know that that is the mass number. And if that's the mass, then this is known as the atomic. Mg stands for magnesium. Now, magnesium is a very common element that you will see in your exams. Make sure you're familiar. Make sure you're familiar with recognizing this symbol, or equally, make sure you're familiar with actually recognizing this name and then converting it into a symbol. Before we finish this quick video, we're trying to keep it under the 10-minute mark. We just quickly need to run through this idea of groups. You can see from our flowchart here, we have detailed 3 groups. We've detailed group 1, which is known as the alkali metals. We've detailed group 17, or 7 it's commonly known as, which are called the halogens. And then group 18 or group 0. They're both interchangeable. If you ever hear the word group 18 or group 0, it means the same thing. And they're known as the noble gases. Say my teacher asked me, please could you identify all of the elements in, let's just say, group 1. So what we would do is we would go to the first column in the periodic table. Now, a column is something that goes up or down. So I'm going to go to the first column, which happens to be this one. Let me highlight it. You can highlight whilst we are doing this. Let's choose blue. So we're going to highlight all the way down here, all the way down here. So that essentially means that all of these elements that go up and down here, up and down this column, are known as group 1 elements. You can do this exercise for another one of the groups that we have spoke about. So we could do it for group 17. So let's go ahead and go to the 17th column. That happens to be this one right here. Let's just go ahead and quickly highlight all of this so we know which group we are talking about. So it's any element that goes up or down this column here. So if your teacher asked you, please could you identify group 17 or group 7, it's commonly known as, you would literally do exactly what we've done. You'd highlight, and then you would quite literally just say fluorine, chlorine, bromine, iodine, and so on. The last one you probably are expecting me to go through is group 18. Now that is known as the noble gases. Just go ahead and go all the way over to group 18. And what we're going to do is we are going to highlight this nicely. Let's go ahead and just draw this in. And essentially what that means is that any element that goes up or down this column here is known as a group 18 element. So now we've gone through this idea of groups, how to identify them on the periodic table. What we're going to do now is quickly run through the 3 main group types you need to know. That's group 1, group 17, and group 18. So I know we have touched on this, but we're just going to reiterate a couple things. Group 1 elements are known as the alkali metals. Group 17 are known as the halogens, and group 18, i.e. group 0, are known as the noble gases. Now, typically, and we will get to this in another video, typically group 1 and group 7 elements like to react with each other. So we can almost just draw little arrows like this. The reason why they react with each other is because they make each other happy in terms of their electrons. If you're unsure about this, just drop it in the comment. We will get back to you with a video, and we are publishing videos all the time about these subjects. But always think group 1, group 7, they love to react. And then the most unreactive group is the noble gases, which is group 0. The reason why they're unreactive is because they have a full outer shell. And again, we're going to get into a breakdown of that as well. But the purpose of this video is just making sure you guys understand the periodic table, understand that it contains elements, understand that groups are within the periodic table, and then identifying those mass and atomic numbers. Now, hopefully that all made sense. We try to keep it under 10 minutes. We're going to continue this series, and we will see you in the next one. If you watched the entire of this video, well done. That's super, super good effort. And we'll see you very soon.